Okay? All right. Hello, everyone, and welcome. My name is Rod Stallmuller, and I'm the Senior Director of Product Marketing for the NSBU, the Network and Security Business Unit at VMware. And I'm really happy to be here talking with you. I really can't see anybody, but I want to try to get a little bit of a hand raise here. How many of you all are virtualization specialists? Server virtualization, okay? How many are networking guys? Okay, great. How about security folks? All right, great. So that's a big difference. I've been here, this is my fourth VMworld here in Barcelona, and I came from the Nicira acquisition in 2012, where I was actually with Nicira back in 2010, so I've been doing this network virtualization stuff since it was science fiction. And it's really great to see now at VMworld a lot more networking people coming to VMworld to learn about NSX, and hopefully today you'll get a lot out of this introduction session. I guess I need to put the disclaimer up here. I'm a marketing guy, so you can't believe anything I say. All right, so what this is really about is we're going beyond server virtualization. We all understand what server virtualization is and what server virtualization has done from an operational standpoint in the data center, but now we're going and we're transforming every industry out there through the use of network virtualization. And just to get started, to give you an idea of some of the customers that we have out there, I threw a few of the logos up here, but I wouldn't be able to even put all of the logos on the slide these days. We have customers in every single vertical out there. Some of these customers are very large customers, some of them are small customers, but for instance, eBay is one of our larger customers, has 60,000 VMs connected to logical networks running on NSX. We started in the service provider space where companies like AT&T and NTT and Rackspace and people like that have been using NSX since 2011. We then moved to the global financials, so people like Citibank and Goldman Sachs and JPMC and HSBC, ING, all of these are using NSX. Right? And so all of these customers have started to see the benefits, and I want to make something very, very clear because there's a lot that goes on in the media, right? The media absolutely loves a fight, right? Especially a David and Goliath fight. So you read a lot about how VMware and Cisco are at odds with this network virtualization stuff. So I want to make it very clear to you that we love Cisco. A lot more than Cisco loves us, but we love Cisco. 85% of all of these deployments are running on top of Cisco gear, right? So this is adding a capability into the environments that you already have. And sometimes this is old Cisco gear, sometimes it's brand new Cisco gear. So as I go through the presentation, understand that what the underlying physical infrastructure is doesn't matter to us. And it shouldn't matter to you. You'll be able to use the gear that you choose to use, whatever that is. Okay, so there's a lot of things that are driving the need, and I'll talk a lot about security, I'll talk about speed and agility, but NSX is addressing a lot of the things that we've kind of had to deal with in networking and data center for many, many years, and now we're changing the way that things happen. It's time for this new approach. This is something that you'll find as we go through this presentation, that this is a new way of thinking about how to approach the problems that we have in the data center environment. What we're doing here is we're taking a new approach called software-defined data center. Now, I'll describe that a little bit more as we go through, but software-defined data center is often you hear it from VMware as a VMware product. It's not really a product. It's a new approach that allows you to take advantage of compute virtualization, storage virtualization, and then key to the whole thing is network virtualization. And that's what the session today will be about, understanding what this is and exactly how it works. So going back to that software-defined data center approach, If you think about everything that we've grown up with, we've learned over the last 20 years in terms of networking, it's really been about services that are delivered in hardware. Vendor-specific infrastructure, lots of manual configuration and management. It's how we all grew up. It's how we all managed networks over the last 10 or 15 years. But now what's happening is services are being distributed in software, right? So that we can get the operational model of a VM for the entire data center construct. And we're leveraging a lot of automated configuration and management to do this. Now, the underlying physical infrastructure doesn't go away, right? It needs to be there. Something's got to forward packets across the wire. But what happens is it becomes more of a pool of compute, network, and storage capacity that now through software has the ability to be provisioned and repurposed on demand. And that's not SDN. That's not software talking to the hardware. That's actually creating these network environments in software above the physical infrastructure. And that allows the physical infrastructure to actually become a lot more simplified and reliable, right? Think about all of the troubleshooting that goes on in the physical infrastructure today. Most of that troubleshooting isn't because a Cisco switch catches on fire, right? It's because somebody did a manual configuration that now broke a VLAN or broke some ACL or added an ACL or put a firewall rule in or something that caused now an issue that people have to track down. If you simplify the physical infrastructure and you don't have to do that configuration in it, then you eliminate a lot of the problems that today we spend our time troubleshooting. So if we look at a typical enterprise environment, which many of you fall into this category, we take the enterprise applications and we bind those to the services that are delivered through the hardware. So things like isolation and switching and routing, firewalling, load balancing, all of these are services that are typically configured in the hardware and then delivered as part of the application environment, but become part of this long process of delivering that application environment to your business customer, because those things have to be thought about and configured and reconfigured and troubleshoot. And as things move around and become even more dynamic, they become more difficult to configure and manage. But if you look at what the big guys have done, and I know you're not the big guys, right? I mean, nobody is like a Facebook or a Google in terms of their data center. But what these guys have done over the last 10 years is they've moved those services from the hardware infrastructure, from the physical infrastructure, into their software. So they actually put it into their custom applications. But this isn't something that a typical enterprise has the ability to do for a couple of reasons. One, you don't have the staff and the people necessary to do this kind of coding. And two, you can't modify your applications, right? You don't own those applications from the standpoint of being able to change them. They're typically off-the-shelf applications. But by doing this, what the Googles and Facebooks of the world have done is got the software automation, the agility and speed, the distributed network services in software that allowed them to simplify, make more stable and lower cost in their physical infrastructure, because they decoupled. They put an abstraction layer very similar to the way we put an abstraction layer between the server and a VM. So what VMware has done is actually move those services into the data center virtualization layer. So now you can get that same abstraction from the underlying physical network, get the same benefits of that abstraction, but without having to modify the application in any way, because now those services are running in software, but in the virtualization layer. And that's essentially the basis kind of for what we're doing here. And the rest of the presentation will go a little bit deeper into exactly how that works. So this gives us the ability to do the operational model of a VM. So just like we can programmatically create a VM, right? We can snapshot it, we can move it, we can delete it, restore it, do all those things that completely transformed the operational model of servers. Now we can do this for the entire data center construct, all of the networking, all of the connectivity that's going on there. So if you're like a lot of customers, sounds interesting, but sounds like a very big change. Not even sure we understand what network virtualization is yet. So let's drill down a little bit deeper and start looking at that. We want to move from sort of the traditional approach and the traditional thinking more into this software-defined data center approach. So first, think about the physical infrastructure that you have in place. All of you look something like this. You've got server physical infrastructure, you've got storage physical infrastructure, and you've got network physical infrastructure, connecting all of these things together. And like I said, this could be, for NSX, any network infrastructure. It could be Cisco, it could be Arista, HP, it could be, Dell, white box networking, it could be anything underneath there as long as it forwards IP packets. Does anybody have a network that does not forward IP packets today? Okay, good. So we're in good shape from that standpoint. Okay, then since you're at this conference, the virtualization layer is likely vSphere. So now you have this virtualization infrastructure running there. It's already in place. And now what NSX does is it adds those services into the hypervisor that allow us to create what you can think of as a network hypervisor. So like a server hypervisor is a thin layer of software that allows you to create that software container that represents the x86 environment, so I can put an operating system or an application on top of it, but I can do all those fancy things about moving around and so forth that change the operational model. Now I can create a software container that represents the network environment. So in that software container, I have layer 2 switching, and layer 3 routing, and firewalling, and load balancing, and QoS, and ACLs, and everything that the connected workload is expecting from a network, but now in software in a way that it can be programmatically created and snapshotted, moved, deleted, restored, all of those things that we do with a VM, but now for this entire network construct. And I can create thousands of these containers for each one of my applications. Now, it looks like things are grouped together in this container, but think of this more logically, that these workloads that are connected here could be anywhere in the data center or across multiple data centers and be part of that logical entity. Whether that's an L2 connection or an L3 connection, it's the entire network environment there. Now, a lot of networking guys will look at this picture and say, well, that looks pretty cool, but in order to do that, you need to talk to that box. You have to be able to configure VLANs and ACLs and firewall rules and all of the things that we do in the data center and the network all day long. The reality is we don't. And so think about it this way. Think of a physical network chassis. It has sheet metal around it and a backplane and line cards that plug into the backplane. Nobody goes and configures VLANs or ACLs or firewall rules on the backplane. The backplane's job is simply to move packets as fast as possible from any line card to any other line card. All of the intelligence of what to do with the packet is actually running on the line card, right? How am I going to forward this? Am I going to filter it? What am I going to do with this packet? So now if you think of each one of the hypervisors in the data center as a line card plugged into a big backplane, that's what the underlying physical network becomes. It becomes a packet forwarding backplane, right? So that now I can simply move packets as fast as possible from any hypervisor to any other hypervisor. All of the intelligence about what to do with the packet is actually running in the hypervisor. So now we'll go a little bit deeper and kind of talk about how all that works. So for one thing, this is a distributed system. So as I talk about these things, don't think virtual firewall, virtual load balancer, virtual thing. It's a distributed service that now runs on all the hypervisors. So the firewalling capability, for instance, is not a virtual firewall running on every hypervisor. It is a distributed service that now I can apply rules to every single VM and then apply that filtering in the hypervisor. So it's like having a giant firewall that I'm managing from one place. And since we operate these things using the kernel speed, the kernel capability, I now get capabilities like very high throughput rates. I can do 20 gigabits per second of firewalling capacity per hypervisor with 80,000 connections per second with 100 rules applied. And this is distributed across all of the hypervisors. So as you scale out your application environment, you're scaling out your security environment at the same time. You're scaling out your layer 3 routing capability. You're scaling out your switching capability. All of this is being scaled out as distributed services among these hypervisors. So let's take a look at what the end result looks like. This is VRealize Automation Center, back when it was called vCloud Automation Center. But that's a quick video where I click on a 3-tier blueprint here. Right? It brings up the blueprint, and I see app tier, database tier, web tier. I clicked on the web tier, added a couple of workloads, hit submit. Then the engineers give me a really useful screen that says that I hit submit. And then I go to requests, and you see in progress there on the top. Less than a minute later, it's successful. Okay, very impressive. So what did that do, right? What that did was created everything inside this blue box. So this blue box is that software container that I'm talking about, right? So here I've created 3 layer 2 switches, a layer 3 router that's connecting them together, so essentially turning those into layer 3 subnets. I've got 2 workloads on the web tier, 1 on the app tier, 1 on the database tier. All of the firewall rules and everything that are associated with those, so the web tier can talk to the app tier can talk to the database tier, but the web tier can't talk to the database tier, and the 2 web tier workloads can't talk to each other because I've set it so why do they need to talk to each other? So I'm going to eliminate that communication. And then in this case, I'm using NAT to get to the outside world through the routing, but this could be static route, this could be BGP dynamic route, doesn't really matter. And I do all that on top of the existing physical network without talking to it or reconfiguring it or changing it in any way in 45 seconds, right? So a typical enterprise, so you guys think about how long it takes you to deliver this environment from scratch. A typical enterprise, this takes 3 weeks to a month. When we first went to eBay, it used to take them 30 days to do this. They process re-engineered that down to 7 days, and they were very proud of the 7 days because from an industry standard standpoint, that was fantastic. And then when we showed them doing exactly the same thing with exactly the same connectivity in 45 seconds, their question was, why isn't this in production now? And soon it was, and like I said, now they have 60,000 VMs connected to thousands of virtual networks across eBay and PayPal and all over the place. So what I showed you was in the second column here, which is ViewRealize Automation, kind of a self-service, predefined, click on it, deploy that environment, right? But most of our customers haven't made it even to that stage. Most people are doing the first stage, essentially doing IT, automating IT. So that instead of 3 weeks to a month, they get a request and that afternoon they deliver it. So now they're delivering services at the same speed that the shadow IT is going to Amazon and spinning up workloads, right? Where a typical enterprise data center has been very handcuffed to the physical topology, the physical infrastructure, all of the processes of deploying new VLANs and configuring and doing firewall rules and everything, where you could spin up a VM in a few minutes, but it took you the rest of those couple of weeks to get all the rest of that infrastructure put together. But we also see people doing, end user custom deployments where they're using OpenStack and big community clouds using OpenStack. NSX is the underlying logical infrastructure for the largest OpenStack clouds in the world, including AT&T and NTT, Rackspace, eBay, Yahoo. All of these guys use NSX as their logical infrastructure on top of pretty much every physical infrastructure out there. Okay, so I want to show a quick video. This is a 2-minute video just to give you an idea from a customer perspective. This is Tribune Media, who's a big media conglomerate out of Chicago. And he's got some interesting things to say.
With a total of 42 owned or operated broadcast stations across the U.S., Tribune Media has become one of the nation's largest independent broadcasters. And as it continues to transform its content, service, and delivery, data center security has become priority one.
I've lived the world as a CSO, Chief Security Officer. I've also been a CIO, and I've been a CTO. So there's not many things I've gotten excited about where I could have all three hats. When I saw NSX and I went to my team, everybody kind of had their different viewpoints. I'm like, you don't understand. This isn't a step. This is an evolutionary leap in capability around operations, around security. We needed a platform to absorb SaaS applications, and we needed to have a platform that would change the security geometry that there was today. The answer was pretty simple for us. It was VMware with the hypervisor and NSX. So we set up a pilot, we put NSX in, and the bell went off. We can do this. In 5 months, we moved 141 apps onto the infrastructure, and we had 9 help desk calls. So guess what? It works. With the NSX platform, I can move networks. I can move everything. So if I'm getting attacked, I'm just going to move it. So if I have something on my internal cloud and I want to move it to an external cloud, all of my security moves with it. And that's awesome. I'm here to help the business units, and I'm here to keep it secure. But you step back a little and you look at literally we've gone from the Flintstones to the Jetsons in less than 18 months.
Everybody knows the Flintstones and the Jetsons, right? It doesn't work as well in Asia. They don't know the... Okay. So now we'll drill down a little bit deeper, right? So we'll go down into a little bit more about how this works. But that gives you an idea. I mean, this guy did a pilot, said, okay, we can see how this works, and then moved 141 applications in 5 months with 9 help desk calls. Most of you get 9 help desk calls a week, a day on the network, right? I mean, these are lots of challenges out there. So let's look at it. What are you used to today, right? Today you all have server virtualization, you're all running VMs, and if those 2 VMs need to talk to each other, they're going through the vSwitch, right? We have more virtual ports connected to workloads than physical ports to workloads. We crossed that back in about 2012 in terms of data centers out there. So everybody's already doing some little form of virtual networking. You're using the virtual switch. But if I put one of those VMs on a different subnet, now what happens? The packets flow out, they go across the physical network, they go across the core, they hit the core router, and they get routed back just to talk to that VM right next to it, right? So as we've seen an increase in east-west traffic because of application design, right? Web tier, app tier, database tier, every time I move between those tiers, I'm doing this kind of hairpinning across the physical infrastructure. So now let's look at it from a virtual network standpoint. So in this case, I'm representing the virtual network up there as a box, a thing, but it's not really a thing, right? It doesn't exist in any one place. It's these little green boxes that you see down here distributed out across all of the vSwitches, right? So those little green boxes represent layer 2 service, layer 3 service, firewalling, and ACLs, QS, all of those things. So now if I have 2 VMs and I say connect those to a single logical switch, the packets flow exactly the way they did before, using the layer 2 service, which is that first green box. But now if I put one of those VMs on a different subnet, what happens is the packets flow down, whoops, and then they use the layer 3 service as well. So it actually routes right there in the hypervisor and hands that packet right back up. Right? So now I'm not going across the physical infrastructure using the core router, the core bandwidth, any of that to do this east-west routing for workloads that are sitting right next to each other. Right? Even if those are distributed a little bit, it's just going to use the aggregation portion of the network and route using the logical infrastructure. So then if I want to put another VM on the other side of the data center across multiple subnets and availability zones, I don't go out and reconfigure anything to configure a VLAN to make sure that I can get to that workload or anything. I can go to any available compute anywhere, spin up a VM and say connected to the same logical switch, and those two green VMs are now L2 adjacent anywhere across the data center, even between two data centers. And the packets essentially are flowing across the physical infrastructure to do that. And I'll talk a little bit more about how that works as we go through. So as I mentioned, the way this works is you use a cloud management platform, you use NSX Manager. When you go to deploy a VM, you say, I want to deploy this VM, and it essentially uses APIs to talk to the controller and say, push down the network services that are associated with that VM. Right? So remember, if I'm saying that that's layer 2, layer 3, and the third one's firewall services, so the firewall services are running right there for that VM. And if that VM ever moves, all of those little green boxes move with it. So automatically the security services, all the network services, no matter where it works, where it moves, completely independent from the underlying physical topology, move with it. All those services move with it. So now when these two VMs talk, what happens is the packets flow through those services. And if, like I said, that third box, if that's the firewalling service and it doesn't pass the firewall policy, it would get dropped right there at the virtual interface. It doesn't go out across the network and hit the firewall and get evaluated out there. It gets dropped right here. If it makes it through those services, then it gets encapsulated. Don't be scared about encapsulation. Right? Encapsulation just means that I stick a header on the front end of the packet, fire it across the backplane, and take the header off on the other side and pass the packet up. So the packet that left this VM enters that VM on the other side. Right? We've been doing encapsulation for a very long time. MPLS, OTV, Lisp, GRE, IPsec, on and on and on. We've been doing encapsulation forever. It's only become a visibility issue since Cisco doesn't like NSX, right? The reality is you don't have a problem looking at the traffic that's going across the network when it's encapsulated. You can still use NetFlow. You can still use all the things that you use today to look at that traffic. And in fact, we give you better visibility to what's going on in the virtual environment than you've ever had, right? Okay, one of the really cool things about network virtualization is the ability that every virtual network is completely isolated from any other virtual network. So by default, this isn't using ACLs or firewall rules or any kind of blocking of traffic. There's simply no communication path between these, right? So that these can be a multi-tenant environment, or that could be your dev environment and your test environment running exactly the same IP addresses, running on top of the same physical infrastructure, right? So I can move from dev to test very quickly because the application's the same, the IP address is the same, everything's the same. Just to give you an example of how kind of secure this is, the US Army used to go out and build 2 physical network infrastructures at a remote base, completely air-gapped, one for US forces, one for coalition forces. Right? But if coalition forces needed some more of the compute capacity that was over on the US side, they couldn't get to it. It was air-gapped. You couldn't even get to it. Now they build one physical infrastructure with all the compute capacity, and they isolate US forces from coalition forces using logical networking. So now all available compute resources are available to either side at any time. Right? So this is a very powerful way of separating things. Again, not doing firewalling or ACLs or anything, just naturally decoupled from each other and from the underlying physical infrastructure. So for example, a VM running in that virtual network, even if it became a rogue compromised VM, would have no way to actually attack the underlying physical infrastructure because it doesn't even know it exists, right? So I could be running in that green network. I could say those 2 VMs are actually IPv6. This is an IPv6 application running on top of a v4 infrastructure because when it comes down here, it just encapsulates it and put a v4 header on it and fires the v6 packet across the network. So here's another use case we're starting to see a lot of people do, and this is for disaster recovery, right? So how many of you are using SRM or something like SRM, Veeam, or some other, right? So what happens here, right, is you snapshot the VM and its storage. It gets replicated over to the other side. If you have a DR event, right, you recover the VM, and what's the first thing that you have to do, because now it's running over here in a different physical infrastructure? Change its IP address, right? So once you change the IP address, now you're changing the security that's associated with it, and all of this impacts the RTO. So now let's look at it from a different perspective with NSX running in a logical network. So now you have a logical network, you do exactly the same snapshot, you're doing exactly the same replication, but at the same time, the controller that controls the network infrastructure is also being replicated and kept in sync between your primary and your recovery data center. So now when you have a DR event and you spin up that recovery VM, you don't have to change the IP address because the network and the security that it's expecting is already running there. And you could even run so that you have DNS being advertised out of both of these data centers, and you just make the recovery site a much more expensive link, so it's always going to default to the primary site unless the primary site's not available, and then it goes to the default site. So this is one of the things that we're seeing people apply NSX to. Like I said, there's a lot of use cases of NSX. This is just one of them. So I've talked a lot about VMs and how the VMs get connected and so forth, but we also support physical workloads. It's another bit of FUD that's out there in the world. And we do that two ways. One way is through an x86 gateway. So this is just a server running some NSX software, and I can connect physical workloads, and I can connect legacy VLANs of physical workloads or virtual workloads to that, and essentially those devices become L2 adjacent to the VMs that are running here, because essentially you're mapping either that physical workload or that VLAN into the logical network, right? So this is how somebody like Tribune Media moves 141 applications over into the new infrastructure. They just take the workloads that are running on the VLAN and vMotion them across the gateway into the new logical environment, right? Now they can utilize the capabilities of the logical environment. The other way we do this is through our top-of-rack partners. So Arista, Brocade, Cumulus, Dell, HP, Juniper, all of these guys have done OVSDB integrations that make it so the controller can talk to the switch and map a switch port to a logical network. So whether it's a physical workload or a VLAN connected to it, it's mapped in and they become L2 adjacent. There's another C in there that does it, but you'll have to ask them about it. Okay, so here's what many of your infrastructures look like. Typical 3-tier Cisco 7000 environment, right? So just like we talked about it before, if I've got two VMs running on a blade and I need to route between them, I'm going across the oversubscribed core. Now we offload that routing into the hypervisor. Even if I'm on two different blades, I'm only using the aggregation portion of the network to get those packets between the VMs. So what this does is it actually allows you to extend the life of your 7000 infrastructure for whatever reason. So for instance, let's say you are still depreciating it because you invested in it a lot here recently, last few years or something, and you want to extend the life. You can get this new operational model and do that on top of it and extend the life, because you're going to not have to invest more into your capacity because we're offloading that capacity. You don't have to buy more 7000s. You can take that money that you're saving and apply it to your 9000s that you want to buy because you want to move to a leaf-spine architecture. Most people do want to move to the leaf-spine architecture. So if you're moving to a leaf-spine architecture, the last thing you want to do is invest more in your 3-tier architecture. So one of the things that NSX does is allow you to extend that life and get to the point where you can move to the new architecture. This is exactly the same picture, except for now I'm hairpinning out to the firewall in order to apply controls between these two VMs. Right? Today everybody's doing a good job of perimeter defense, but doing the controls at the virtual machine is very difficult. And this becomes the basis for our microsegmentation use case of NSX. So what I'm talking about with microsegmentation is this. If you think about every single one of the attacks that we've all read about going over the last couple of years, whether it's Target or Home Depot or Sony or the US federal government, right? What happens is the threat gets in, however it gets in. Once it gets in, because there are little or no controls for lateral movement, that threat can move from server to server to server until it finds what's interesting, and then it starts pumping credit card data out. That is common to every single one of the attacks out there. So from a security standpoint, over on the right side, the security team, it's been nirvana to say, hey, I'd like to be able to do a zero trust infrastructure, be able to create this kind of honeycomb effect so that I can contain a threat to a certain area. But even that certain area could be dozens or hundreds of servers, because once you start adding more and more and more firewalls to be able to have the capacity to look at all that east-west traffic, it becomes operationally infeasible to kind of keep up with it. And the reason that it becomes operationally infeasible is because the packet leaves the VM, it goes across the network, and gets evaluated and enforced at the firewall. But what that means is that when I provision that VM, I have to update the firewall. I have to create the rule. I have to look at the policy. Okay, what kind of VM is this? I got to write the rule. I got to make sure. Might have some human error involved there. Who knows? Puts that into the firewall, right? And if that VM ever moves, I likely have to update the firewall. And if I delete the VM, I should delete the firewall rule. But you all know what happens there. Should I delete that firewall rule? No. Why not? Because my phone might ring, right? So you leave the firewall rule, and then what happens? A few months later, you're spinning up a new VM, same IP address, application doesn't work, everybody's trying to figure out what the heck's going on until somebody digs into the firewall and finds out that there's this rule that's blocking the traffic. Or worse, it's actually allowing a hole that nobody knows about, and nobody's phone's ringing on a hole, right? So, how do we fix these problems? We make it so that when you provision the VM, you're provisioning this firewall rule policy with the VM. Remember, you've got now this distributed firewalling capability that's now at every one of your hypervisors. So now, when I provision the VM, the firewalling capability is right there. So when the packet leaves, it gets evaluated and enforced right at the virtual interface. So now, if the VM moves, all of the rules move with it. Completely automated, no human intervention at all. This is just all automatic. And if I delete the VM, the rules are gone with it. Again, completely automatic, no human intervention. So what I've done is essentially automated all of the things that made it operationally infeasible to do controls all the way down to the virtual interface. I've made that possible by having security built into the infrastructure, baked into it, instead of being bolted onto it, which is the way we've done it for years. So one of the cool things about this is it also enables a way of doing security and security grouping that doesn't have to be based on IP address. It doesn't have to be based on ports and protocols. It can be based on, what is the operating system that happens to be running on this VDI workstation? What's the machine name? If I'm really good at, naming my machines and having naming conventions, I can apply security policies to those naming conventions. Regulatory requirements. Is this a PCI workload? Does it have customer data? What is it? And those kinds of things can be applied and say, I can apply these rule sets to that kind of workload because of the kind of workload it is, not because of the IP address that it has, right? So for an example there with the operating system I was talking about, let's say I've got a bunch of VDI workloads, but I have some people that are running old, let's say Windows 2003 operating systems, and I don't want those things talking to anything. Maybe I'll allow them to get to email, but that's about the only thing. So I can create an unsupported OS group, and whenever a workload gets created and comes up with an unsupported OS, then it applies a DMZ policy around that doesn't allow it to get to the things that I don't want it to get to. Where other VDI workloads could spin up and have a more modern or a later version of the operating system and be able to get to things. So part of the way we make this all automated is we make the policy machine readable, or at least you can think about it that way. Right? Today, policy is human readable document, right? I'm going to deploy this kind of workload. What does it have? It's this and that. I'm looking at what's the policy on that, and I create the rule based on that policy. Here, we allow you to define what the policy is for all these different kinds of workloads that you might have, so that when I go and say, I'm going to deploy a production workload on the database tier with customer data and PCI data, the system already knows what the rules that are supposed to be associated with that kind of workload are. So I provision the workload, and I have the rule set necessary to be applied to it automatically, and nobody makes any mistakes because that's already been predefined. Those things feed a log file that can be consumed by your existing audit tools. So allows, denies, redirects, all of the things that you're used to in your firewalls is happening at the firewalling capability that's built into the system now, and you can do the same audits. But there's some interesting things that happen with the audit. So for instance, if many of you have to deal with PCI, and a PCI audit basically says I need to audit all the workloads that are on this side of the firewall. Whether they have PCI data on it or not, they're part of that segmentation. Well, if the segmentation is microsegmentation and goes all the way down to the virtual interface, now I only have to audit the machines that actually have PCI data on it. Because now the firewall and the segmentation part of PCI is happening right at the virtual interface. So it can reduce the scope of an audit. So it's very important to understand that I'm not talking about replacing the north-southbound physical firewalls. Those things have a purpose, they're in place, they're doing exactly what they're supposed to do, getting 100 plus gigabits per second out of them. But I'm also not talking about a virtual firewall. Right? Every firewall company out there has the virtual version of their firewall, but you go from 100 gigabits a second down to 1 gigabit per second, and you haven't changed the operational model at all. You still have to update all the firewall rules and so forth. So this is why you don't see virtual firewalls all over everybody's data center. Right? What I'm talking about is distributed firewalling that's now baked into the platform. So I get this automated policy management operations, I get distributed enforcement down to every virtual interface, and I get kernel-based performance. So I mentioned before, but we're getting 20 gigabits per second per host, right? So as I scale out the application environment, I'm scaling out the firewalling capability. Now I get a lot of questions on, okay, so now the firewall's doing all of this stuff, or the hypervisor's doing all this stuff. How does that affect the performance of the hypervisor? On the left here, you see no filtering. vSphere is doing about 20 gigabits per second. When I turn on filtering with the firewall doing its thing, I go down to about 19.7 gigabits per second. So very little effect on the hypervisor's ability to move packets, and I can do 80,000 connections per second with 100 rules applied. And again, this is per host, right? So it's only applied to the VMs that are running on that host, and I get another 80,000 connections per second for the next hypervisor. So you can see as this scales out, it can become a pretty big, powerful firewall that's managed from one place. So as we talked about, we can create these completely isolated environments. That's one part of security, keeping the whole thing completely isolated. But then I can do explicit allow. Right? So this is our firewall. Our firewall is a basic firewall. It's kind of a source destination port protocol type filtering, right? Based on, but you can base it on naming and so forth. It doesn't have to be based on IP address. Now, you could easily argue, and I would agree with you, that you need deep packet inspection, next generation firewalling capability on the perimeter because you're allowing things like HTTP port 80. You have to. But anything can go across HTTP port 80, so you need to do deep packet inspection and not allow the things that you don't want to. But inside the perimeter now, you know that your application server is talking to your database server on this port and protocol. So create the rule that says that's what should be happening. Everything else should be dropped. And that eliminates that threat's ability to move from server to server because it's trying to do it over other ports and protocols. Now, that said, this is the basic capability. We also have partners that give you the ability to do deep packet inspection. So you can see out there on the show floor, there have demonstrations from Palo Alto, from Checkpoint, from Trend Micro, from Intel Security. All of these guys have taken advantage of the distribution and the automation of the NSX platform and are now delivering their advanced feature set all the way down to the virtual interface as well, right? And the way that works, and I'll use Palo Alto as an example, but this is how Checkpoint works, this is how Intel and Trend, all of these guys work, is the management console registers with NSX and pushes down the VM series of their products. So in this case with Palo Alto, this is their VM series. This is a virtual firewall, right? This is the same capabilities of the north-southbound firewall running in a VM. But you go from 120 gigabits per second to 1.2 gigabits per second, right? So now what happens is we have the ability to map the security policy for those workloads that need that deep packet inspection onto our firewall, the distributed firewall here. So now when the packet leaves the VM, if it needs the advanced feature set, we steer that traffic into the Palo Alto VM. So now it can be now you can apply deep packet inspection. But the nice thing is it's only having to look at the VMs that are running on that hypervisor, and actually a limited set of those whose policies say they need the deep packet inspection, right? So when you combine this distributed firewalling performance with the automation and the audit compliance and the deep packet inspection capability with our partners, all of a sudden you have a microsegmentation solution where you can apply controls down to every interface inside the perimeter in a way that's operationally feasible. So in the end, with NSX, you have the ability here to create isolated application environments, apply stateful firewalling capability down to every virtual interface, apply advanced capabilities where those are necessary, deploy those anywhere in the data center, completely independent from the underlying physical topology in any way, even between multiple data centers. Have things like, your web tier and your database tier running on the same hypervisor but not even able to talk to each other. Have the application portion running somewhere else in the data center but looking like it's all clustered together. And if anything ever moves, nothing changes because all of the networking, all of the security, everything that was associated with that workload moved with it. Again, completely independent from any kind of topology that's going on in the underlying physical infrastructure. So there's all kinds of different use cases. I covered a few of these, the microsegmentation under security, the IT automating IT, meaning I'm spinning up these environments very quickly in speed and agility, and then disaster recovery in application continuity. But if you look, there's other ways to apply things like microsegmentation. So what we call DMZ Anywhere, this is essentially VDI workloads that, when you spin up a VDI workload today, you're having to say, okay, I need to make sure that this thing spins up in this physical topology behind this firewall so that it can only get to the things that it needs to get to. When you apply that with NSX, you can spin up that VDI workload anywhere and essentially create its own DMZ to what it can get to from wherever it is in the data center. Secure End User is our combination of AirWatch with NSX. So if you take AirWatch today, today mobile devices, you create a VPN and pretty much the applications on the mobile device can get to anything that's on the other side of the VPN, right? Now with NSX, you can say this application can get to these resources and this application can get to those resources, but they can't get to the other resources. It's a very powerful capability to limit exactly what each application has access to in terms of the data in the data center. Developer Cloud, of course, is something where people are using the speed and agility to spin up their dev environments, to do testing, to do things, and a lot of times this gets driven directly by the API, so you see it involved in DevOps and so forth, where people are spinning up the environments themselves. A lot of times we see OpenStack being deployed in that kind of environment. Multi-tenant infrastructure, whether that's an enterprise that has the need to separate different groups, or it's a service provider who actually has different tenants using the same infrastructure, we have the capability to do that. And then I talked about disaster recovery in the active standby mode, but we also do what we call metro pooling, which is essentially the active-active. So now you can have two data centers, and instead of having to have OTV kind of capability to do connection between the data centers to stretch the L2, now you can take a logical network and stretch it across two data centers just using an IP connection. Right? So now you can have an active-active environment for an application where if this data center goes down, the application keeps running over here and vice versa. And then, of course, hybrid cloud, where things like vCloud Air, we now have the ability to move workload with all its security, all its networking capability, and move it over into vCloud Air, move it back, and it keeps all of that security as you move things around. So again, a great partner ecosystem. We see more and more partners actually integrating with the system. You'll see a lot of them on the show floor. I encourage you to go by, ask them what they're doing with NSX. These guys are all showing demos about how their products work with NSX and how it makes things a lot easier to use. Some very powerful capabilities from a lot of our great partners out here, and these guys are represented on the show floor, so please go take a look at what they're doing. So one last video from a company called Xestar.
Xestar serves the identity and access management verticals for aerospace and defense and life sciences, and we also do secure collaboration and supply chain in the cloud for our customers. For Xestar, NSX has been strategic in a number of different ways. Primarily, it allows us to have a lot of control, a zero trust model at the network layer. Network virtualization for us is kind of the holy grail in terms of having a portable workload that we can move from one data center to another and do it in a secure model. And that has been something that we have not been able to do until we have come across NSX.
We've seen VMware take a great interest in evolving the product. I think even today, probably beyond what other competitors can do.
Prior to NSX, we, like most IT companies, had a workflow that involved, physical firewalls, a lot of processes, and these would span weeks at times. And now with NSX, that goes down to hours or minutes at most because of the automation involved, because of the virtualization in our control.
We chose NSX over the competitors such as Cisco, ACI, simply because of market adoption. NSX has gained much more momentum in the marketplace and seems to have broader acceptance by the partner ecosystems than the competitors that are coming up.
NSX has been game-changing because it has a demonstrable reduction in level of effort. So when we're reducing our time to deployment by 80%, that leads to savings that we can deploy folks on other projects.
My job is to work myself out of the job. I want to make my job so easy that I can do other things.
For Xestar and its customers, what we're seeing is for disaster recovery, the bar is getting higher and higher in terms of the data we're protecting and how fast we can bring it back online. With NSX, now what we're able to do is basically take that container, always have it in our DR facility, and when we need it, we can basically, at a push of a button, bring it online and bring our customers back online.
So my advice in getting NSX deployed in your environment is to start from the bottom up. To start with your regular network administrators, your regular sysadmins. It doesn't have to come from management. Once you start to see the visibility that you get, you'll never miss the command line.
So we've got a lot of support out there. One of the things I want to make sure I get across to you is that NSX is unique in its way that this is something that you can try, right? This is not something that you need to decide, I'm going to re-architect the data center and we're going to do something big. You can get a few hypervisors worth, you can start seeing what it can do, you can let people get used to it, and this is where a lot of people do. They start, they deploy it, they see what you can do, they get people used to it, they get understanding how they would move applications into it, and then they expand from there. This is something that you can start small and grow from. We've got a lot of support out there. We've been doing a lot of interesting things in terms of how to operationalize NSX, since we now have over, I think it's about 160 customers now that are in full deployment capability out there. We've been interviewing them about their best practices and how they moved through the process of getting that deployed. And so we can help you. We're writing a lot of documents about that and how to help your organizations understand how they will move to this new environment. And so lots of services out there, lots of partners that can help you do this. And so I encourage you to give it a shot, give it a try. You won't be disappointed. So you can start by looking at a couple of different places out here, get some training, see when we're going to have different events in your cities that you can go see, get hands-on lab. Go to the hands-on lab while you're here at VMworld. For the last 4 years, NSX has been the most used hands-on lab at both San Francisco VMworld and Barcelona VMworld, by double of any other hands-on lab. So lots of people testing it out, see what it can do. So that's my presentation. I'll be happy to take some questions. I think we've got maybe 5 minutes, and then I'll go out on the side as we exit if anybody has questions out there as well. Any questions, comments, cuss words, anything? No? Okay. Well, thank you very much for your time.